Okay, this is the section on Java syntax for selection and repetition. Selection being if-then-else structures and all of their variations. Repetition being either loops or recursion. We will only cover loops in this section. Again, here are the outcomes. Go back and when you're done with this section and convince yourself that you know these outcomes. Okay, there's 5 things every programming language must do. They must be able to create in variables, or usually that's a declaration. So they have to be able to create or declare variables. Once they have those, they have to be able to bind values to those variables. Normally we call that assignment. Not all languages do. So you have to have some kind of a binding between the variable and the value, and that's what assignment is doing. It's causing that relationship to occur between the variable and the value. And then you have to be able to select sections of code to execute. That's your typical if-then-else structure. I call it selection both to remind you of why it's there, and we'll talk about why you need that in a minute, and also because there's different forms of if-then-else. So selection covers them all. And you also have to be able to do repetition. You have to be able to repeat section of codes. And again, I don't just say looping because there are different ways to do repetition. Normally, the big 3 are for loops, while loops, and recursion. We'll cover for loops and while loops in this talk. And then you have to be able to do input and output, because if you can't do input, you can't control the program. If you don't get output, who cares? If the computation occurred, you never get to see the result. It's that whole tree falls in the forest thing. Okay, so let's talk about the selection, the if-then-else form. The selection is the ability for a program to select which sections of code will execute at any point in time. Why? Well, that's the one way that a program can respond to user input. If you said that you wanted to go left on day 1 and go right on day 2, but no matter what you said, the program went straight ahead all the time, that makes the program useless. It's non-responsive to user needs, and it's also quite frustrating. So this allows the program to change behavior based on user input. Now, when I say user input, we normally think of a user sitting at a computer, like word processor or gameplay. That's the user. But remember, input can come from other forms. You may have a file, a database, and that becomes the input. And the software will do something different based on different values in that file or different values in that database. You can also have data and requests that are sent from computer to computer. So, we live in a highly networked world now. Online shopping, the input to the machine over at shopping.com isn't really from you, it's from your computer. That's a request, and it's data sent from your computer to another computer. And that's happening more and more and more now because more and more things are networked and automated. The selection is typically done by using if-then-else forms. If something is true, do this, else do that. And the basic if-then-else form is required in every programming language. It may look different, but it needs to be there. Everything else is gravy. Additional forms other than the if-then-else, the standard if-then-else exist in virtually every programming language. That's for programmer convenience. That's what that's about. It doesn't add any computational capability to the language. It just makes it easier to program. And when things are nice or sweet for the programmer, but they don't add any real computational oomph, we call that syntactic sugar. So everything else is syntactic sugar. When you want to learn a language, just look for that basic if-then-else, and then you can start to look at, okay, what syntactic sugar do they give me? Okay, so 3 things. 3 things are needed for selection. First, you need to do a Boolean test. You need to have a Boolean test. What is a Boolean test? It's a question, and it's a question or an expression that evaluates to true or false. Boolean logic, Boolean math is the world of 2-valued systems. The 2 values typically are expressed as true and false. Could be also 1 and 0, yes, no, up, down, left, right, but typically we're dealing with true and false, and that's what we're going to deal with in the if-then-else structure. Then you need to do something if the Boolean test is true, and something if to do if the Boolean test is false. Now, one of them might be nothing, do nothing. But that's okay, that's still doing something, right? You're choosing to do nothing. We call if the Boolean test is true, we call that section of code the true branch, and if it's false, we call that the false branch, and that's because we tend to think in terms of logic trees where we're branching down the true and false paths. Once you understand those three things, it makes programming languages and learning new programming languages a little bit less mysterious because you know what you're looking for. You're looking for, okay, how do they do the Boolean test? How do they tell me what to do when it's true? How do they tell me what to do when it's false? Everything else is just formatting. It's just syntax. So in MATLAB, I believe it's if Boolean test, and then it's line feed, I believe, is what indicates the true branch. The else, the keyword else, it tells you when the true branch is done, and then the false branch begins, and the keyword end tells you when the whole if-then-else structure stops. In Python, it's about indentation, if, line feed, indent, else, indent. Notice there's no end statement. That's because it's about indentation. I find that horrifying, but it works. It's legal. And Java, C, C++, many other programming languages have converged on this form in the section in the center here, which is if, and then your Boolean test in parentheses, and then open curly bracket, true branch, close curly bracket, else, open curly bracket, false branch, close curly bracket. Remember, curly brackets in Java always designate sections of code. So the true branch and the false branch are both delimited by the curly brackets. There are other forms. In Excel, if, and then you put inside parentheses the test, comma, true branch, comma, false branch. Excel is a computational language. You can find others. So we're going to focus on this center one since we're dealing with Java right now. Okay, so what is this Boolean test? The Boolean test, in order to have the Boolean test, what we're basically usually doing is comparing two values to each other. Are they equal? Is one greater than the other? Does one contain something? You may have some conditions, like did a particular value go less than 0? Well, that's another comparison, isn't it? So we need some syntax for this. All of these are questions, not statements. So that first one, A equals sign B, it should be read A is equal to B, but it's a question, not a statement. Maybe it should be read is A equal to B. It's a question. Why are they using two equal signs in a row? Well, they needed to have some kind of a nice intuitive format for testing to see if A is equal to B. The equal sign was already used. That's the assignment operator. So using two equal signs. A exclamation point equal sign B. That's not equal to. The exclamation point is called the not operator, and you read it exactly that way. Not. Not true is false, not false is true. And here we're saying that whole expression is true. If A is not equal to B, then that whole expression is true. And then you get the standard A greater than B, greater than or equal to, less than or equal to. You can find more. All of those are questions, not statements. Sometimes you need to check more than one condition at the same time, and you can do that using the Boolean operations of and, or, and not. If you're not terribly familiar with those, I can send you some material, or you can go online and just find the basics of and, or, and not. However, I believe you all took CS222 to get into this course. No, that's not true, I don't think. You took CS223. That's helpful if you took CS222 before this course, or CEC220, because both those courses deal with and, or, and not in detail. Okay, so some basic examples. Here's the canonical standard form. If, some test, do something if it's true, else do something if it's false. That's a legitimate actual Java code right there that will run, compile and run in Java. Normally, I don't know. I think it seems like it's the majority of times you have this form where the false branch is omitted, and if you omit the false branch, you don't need the else, you don't need the curly brackets. It's just this curly bracket here ends the if statement. It may be where you have if Boolean test is true, you don't need to do anything. If the Boolean test is false, then you do something. And of course, my print statements here are just dummies for doing something. It may be that you have this form. Is this legal? Will this compile? Are you allowed to leave the true branch empty? Yes, absolutely, you can do that. Never do it. Never do it. It is against all convention, and it is against the way the human mind works. And again, who are you writing your code for? You are writing your code for humans to understand it. And so humans will understand if this is true, do something. It's a lot harder to process if something is not, if something is true, don't do anything else do something. That's harder for the human brain. So how can you fix this? Oh wait, what would you do to fix this situation? That's what that not operator will help you out with. You could put a not around that whole x greater than y. If not x greater than y, do something. Okay, we can nest these things. By nesting, we mean we place one inside the other, so you can have if-then-else statements inside of if-then-else statements. In theory, you can go arbitrarily deep. If you're going more than 3 deep, you're probably just doing lousy code. So you might want to rethink your design. Now, sometimes, you just can't help it. But try not to do much. I suspect most of you will never need to do anything more than this, which is nesting one layer deep, one if statement inside the other. You can get around this by making more complicated tests at the top level, but sometimes that is more confusing than it is helpful. Else if, the standard else if looks like this. If some kind of a test, x greater than y, do something else if. Notice now there's a new Boolean test. If, test, else if, test, else if, test. You can keep adding these and adding these and adding these. And then finally an else. Do you need that last else? Will it compile and run without it? No. Should you put it in? Every single time. Because you might think that you thought of every possible outcome, and maybe you did, but maybe you didn't. Even if you did, you can't guarantee that your code is going to behave the way you think it's going to, because that's the nature of software, is weird things can happen. Off-nominal conditions can happen. So always put that else, that default else in there if you're going to do else-if statements, because it's your safety net, right? We want to make good, safe, robust code where we always know the state of it. It's always in a good condition. It doesn't crash for weird reasons. So even if all you do there is print, this should never happen. That's a thing to print out, right? And so if you ever see that, oh wait, something weird went wrong. Okay, and then lastly, the switch statement. And the switch statement in Java is used only when you have a variable or an attribute that can take on a small number of very specific values. And by small number, maybe up to 20, something like that. But normally it's less than that. And the syntax of it is a little sophisticated, but it is a nice thing. So you say switch, and then in parentheses, the variable or attribute that you're interested in, or an expression that you need evaluated. And then what a surprise, curly brackets. Inside the curly brackets, you do things by case. Case 1 means if x is equal to 1. Case 2, if x is equal to 2. Case 3, if x is equal to 3. And then you do something, and then put a break statement in. So here, in case 1, if x is equal to 1, we print out tinkers, and then we break. What happens if you don't put out the break? Well, then then case 2 will also execute, and if there's no break there, case 3 also executes. Sometimes that's helpful. Sometimes you kind of want like an entry point and then do everything after that. But normally you just want the one thing to happen. So do the one thing and break. Do the one thing and break. And then put a default statement in there. Always. Always, always, always. You know, x can only be 1, 2, or 3. So what? Put that default statement in there. It's your safety net. Okay, combining logical tests. Yeah, the last slide. Sometimes you need things that are a little more complicated. So you have things like this. Here's a Boolean test and a Boolean test. So this whole expression is true only if x is greater than y and x is greater than z. You can keep combining and combining. You can make this Boolean expression as sophisticated as you want. I recommend not doing that. That tends to be confusing. Again, you're writing code for humans to understand, not for the computer. You're writing code for the human. And you may have understood it today, but you may not tomorrow. So putting in two tests like this with an and or an or operator, normally you can get away with that. If it starts to get more complicated than that, I would recommend replacing this with a method call that returns a Boolean value. This is a nice trick, actually. Some people recommend that you do this all the time. Why? Because instead of seeing x is greater than y and having to remember what the heck that means, you name your test, you name your method with what it is. You name the method with what it's supposed to do. So now people don't worry about the actual actions of the test, it's just what is it doing. And then down here you put in a method, public Boolean, my Boolean test, and now notice what I'm doing. I'm returning, it's the exact same Boolean expression, so the true or false value will get returned, but my readability has been improved. If I need to know what that Boolean test is, I'll go down here and look at it. But if I don't need to know it, why are you thrusting those details upon me and making my brain parse that? So that's a fairly modern coding technique. We used to not do that because it was too expensive in terms of memory, and function calls use up processors. But you know what? Memory's cheap, chips are fast, right for humans. Okay, I'm going to stop here, and then I'm going to pick it back up with the repetition.